All right, so we're being asked to consider cosine of theta, which is equal to 4 root 41 over 41. If theta is an angle in quadrant 4, what is the value of sine? So the quadrants give us a clue as to the value of the numbers, whether they're positive or negative, okay? So here in quadrant 1, remember that x is positive, right? And y is also positive. In quadrant number 2, x is negative, but y is also positive, right? Now in quadrant 3, x is negative and y is negative. And then in quadrant 4, x is positive. Whoops. X is positive, but y is negative. Now that's helpful, and we're talking about x comma y, right? Because it's going to be a right triangle. It tells us the reference angle. In other words, I'm going to have a right triangle that lives in quadrant 4. Our reference angle will be theta. And remember, based on SOHCAHTOA, remember that sine of theta is equal to the opposite over the hypotenuse, and cosine of theta is equal to the adjacent over the hypotenuse. So I've got a little right triangle that looks like this. Where this is theta, and I'm going to zoom in on that a little bit so we can see it a little better. And here's my 90-degree angle. So remember that the side across from the 90-degree angle is the hypotenuse. The one across from the angle theta is the opposite. And then the adjacent is this one here. So when we rationalize the denominator, I gotta be careful how I word this. When we rationalize the denominator, that's where we get the square root. Oh, sorry, first problem of the day. That's where we get the square root business from. Originally, it was 4 square root of 41, and then you multiplied by the square root of 41 on the bottom and the square root of 41 on the top. So this is, what does that tell me? Well, remember that cosine is the adjacent over the hypotenuse. In other words, the square root of 41 is the hypotenuse, and the adjacent is equal to 4. Now that's important because in order for us to find the opposite side, which is what we're going to need for sine of theta, we need the opposite. We're going to use the Pythagorean theorem. So remember, the Pythagorean theorem, when we use it in trig, is going to be the opposite squared plus the adjacent squared is equal to the hypotenuse squared. So we're solving for the opposite. So the adjacent was 4 squared, and then the hypotenuse was the square root of 41. And all of that is squared. And we can't forget our opposite side squared. So when you square a square root, it just becomes the base, which is 41. Over here, 4 squared is 16 because 4 times 4 is 16. And then I have the opposite squared. That's the letter O, not 0. So then I subtract 16 from both sides. And I get 25, right? So the opposite squared is equal to 25. So if I take the opposite squared, which is equal to 25, and then I take the square root of both sides, I get that the opposite is equal to 5, okay? So way up here, this is 5. So it's 5, 4, root 41, okay? So now that I know that, in other words, we're asked what is sine, but really we're being told that cosine was 4 over the square root of 41. Let me make that a little cleaner. So the hypotenuse is still the square root of 41, but now the opposite is 5. But when we label this, the hypotenuse is always positive, right? So this is always 41. And then my adjacent side, right? So this is the hypotenuse. My adjacent side was equal to 4. And that's a positive 4 because really what we're doing is we're constructing this right triangle based on this point here. So the x value is 4, but now the y value, it has a length of 5, right? Remember that when we take the square root of 25, we consider the plus or minus. So the opposite really could be plus or minus 5. So to get to this point here, it's minus 5. Just like I said before, x is positive in the fourth quadrant and y is negative. So it should be x, which is 4, right? To get to this point from the origin, I go over 4 and I go down 5. Now it's not drawn to scale just because it's not. But clearly, this is a negative 5 here. So then this has to be negative 5. So then lastly, I want to rationalize the denominator. I cannot have a square root in the denominator of a fraction. So I multiply the top and bottom by that same square root. So essentially what I'm doing is I'm squaring a square root, and when you square a square root, you're left with the base, which is 41, and then on the top we've got root 5, the square root of 41. That's the answer.